Hello, ladies and gentlemen, Root Beer here. Thank you for joining me once again as we continue our look at the 2006 Pascal paper, and we're on question number 16. An unusual die has the numbers 2, 2, 3, 3, 5, and 8 on its 6 faces. 2 of these dice are rolled. The 2 numbers on the top faces are added. How many different sums are possible? Okay. So we've got 2 of these dice being rolled, so we've got 2 of them that have the 2, 2, 3, 3, 5, and 8 on its faces. In terms of figuring out the different sums that are possible, I think the easiest thing for us to do is just make a little chart. So you might remember from a much younger grade, a multiplication table. Well, I'm going to make the same sort of thing, but it's going to be an addition table. Now, up here we'll have the top face of one of the dice, and you can do 2, 2, 3, 3, but you really don't need that second 2 there. The top faces could just be 2, 3, 5, or 8. Same, 2, 3, 5, and 8. Doesn't matter how many 2s, because if we go back and check, it's not asking us for probabilities. So the fact that there are 2 2s there isn't going to make a difference. Okay. So I'm just going to complete this chart and then count up how many different sums I can get. So 2, 5, 7, 10. You'll notice there's a lot of symmetry here. You could just complete the top half if you wanted. But I've got time, so I'm going to complete the whole thing. 3 and 5 is 8. 8 and 3 is 11. And 8 and 5, 13. So there's our completed addition table. And now let's just go through. I see a 4. I don't see other 4s. I see a 5. Get rid of any other 5s. I've got a 7. 10. Get rid of all these extra 10s. 6. No other 6s. An 8. 11. 13. And 16. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 possible sums. Again, I'd just like to stress the extra 2s in here would just mean there were more 4s and more 5s. It doesn't actually change the number of sums. It changes the probability, certainly, but not the number of possible sums. And our answer is going to be D, 9. Okay. So join me in the next video for question number 17.